Okay, let's continue talking about the compound interest versus simple interest example. Pardon my handwriting on there. So here's the deal. We start with an initial investment of $10,000 and we are accruing interest 5% each month. So instead of yearly, we're just doing monthly in this example. Okay, so remember with simple interest, you're just earning 5% on the money that you invested. So after 1 month, 5% of 10,000 is 500. So at the end of 1 month, you'd have $10,500, and every month you would just earn $500 because it's always 5% on that 10,000. And just for purposes of this example, we're going to assume that we don't invest any other monies into this account. Okay, so after 2 months, you'd have 11,000. After 3 months, you'd have 11,500. After 4 months, you'd have 12,000, and then 12,500 would be your total at the end of 5 months. Let's look at the method of compounding. Right at the end of 1 month, we still have 10,500, but now I'm going to take 5% of that and add it to my original amount. Basically, I'm taking 1.05 times that amount, 10,500, right? And that's how I keep calculating my new amount. So after 1 month, I'd have $11,025, right? At the end of 2 months. At the end of 3 months, I would have 576.25. After 4 months, I'd have $12,155.06. And after 5 months, I'd have $12,762, roughly. Okay, so clearly you can see how compounding actually gets you more money than simple interest. Very basic example, but I just wanted to show you the differences in that. So let's kind of take that idea a little bit further. And what we talk when we talk about compound interest, we're saying, right, we're taking our principal interest, or excuse me, our principal investment plus that investment, right, times R. And then we keep doing that each time. So that's the idea of what we did. And that's what I was just saying. You're taking that P and then you're adding it with that interest rate each time. There's different ways you can compound something. You can compound it monthly. You can compound it quarterly. You could compound it semi-annually, meaning twice a year. You can compound it annually. Some places compound weekly, some daily. There's tons of different ways to compound. Okay, but here's the idea and here's the formula that we use when we're talking about these different scenarios. When we're talking about compound interest, our formula that we use, and this what I use right here is just kind of letting you know sort of the method that we do it, but the actual formula that we use for compounding is this. A is equal to P times 1 plus R over N to the NT. Okay, so that is the excuse me, that is the formula for compound interest. P is your initial investment or initial balance, initial amount, principal amount. You'll also hear that term. That just is your starting amount. Okay, that's your P. R is your interest rate. N is the number of times that you compound it, and T is your time. So those are the different variables that are in that formula. Okay, so R is your interest rate, N is your number of times that you compound, P is your principal amount, okay, and T is your amount of time that you're using. Now that is compounding, you know, a certain number of times each month. But let's talk about a different scenario. Let's talk about the idea of compounding continuously. And you think, oh, what does that mean when you say compounding continuously? Well, that means not just every week or every day or every hour. That means continuously. As soon as you compound it again, and then you compound it again, and then you compound it again. Literally, we're talking down to like a millisecond, a trillionth of a second, a quadruple millionth of a second, whatever monetary or whatever time denomination you want to use, that's compounding continuously. And so when you think about it that way, you think, well, that H value, we talked about E before, and we said if you have 1 plus 1 over n, right, to the n, the larger that n gets, the closer and closer and closer you get to this number, which we call E. The same thing is true here when you are compounding continuously. And some people think, well, that is just fantastic. If I could find a bank that compounded continuously, I'd be set for life, right? Think of these huge corporations that invest millions upon hundreds of millions of dollars. They would be like, oh, I'm going to compound continuously because that's got to be a phenomenal amount of money I make just simply on the interest, simply putting my money in that account. Here's the caveat to that, is that although you're compounding continuously, it actually, because of the structure of the formula, it actually only comes out to be fractionally more than if you just compounded under doing regular compound interest. But right, in theory, it seems like it should be a lot more. But because of that E value, that keeps it as just a fractional percentage above what you would make compounding in other denominations. But this is the formula for compounding continuously, or excuse me, for compounding n periods a year, n periods per year. That's this formula. Compounding continuously, you would use this formula. A equals P E to the RT, the PERT equation. So our variables are the same. P is your principal or your initial or starting amount. R is your interest rate. T is time. But we're using this letter E, and E has that approximation of 2.7. Like I said, it is in your calculator. It is, if you do second and then the division symbol, that will give you E. Okay, so it is in your calculator. Okay, so that's the idea behind that. There's an example. Let me show you an example of kind of the difference between the two ways of compounding, okay? So let's say that we're starting out with $8,000 and our interest rate is 7%, and we are compounding monthly. Compounding monthly. And let's keep this in here for 6 years and figure out which one is actually the better option, whether is it compounding monthly better or compounding continuously better. Let's see which one works out to be the best way to invest our money. Okay, so let's start with compounding monthly. So compounding monthly, we're going to use our formula. A is equal to P times 1 plus R over N to the NT. And so if we plug in 8,000 for P, and then we have 1 plus, our interest rate is 7%. So if I write that as a decimal, that's 0.07. Because I'm compounding monthly, there's 12 months in a year, so N is 12. And I want to see how much money I have after 6 years, so T is 6. Okay, so that's what you would be plugging into your formula. Make sure when you put this in your calculator, you're careful that you follow order of operations. You do 0.07 divided by 12 first, then add the 1 to it. Okay, and then you can raise that to the 72nd power. 12 times 6 is 72. Okay, and then multiply that by 8,000. So make sure you follow order of operations. This comes out to be $12,160.84. Okay. Now, if I compounded continuously, I'm using this other formula. And so when I plug in, I still have 8,000, and I have E. R is 0.07, and T is 6. Okay, and so that I can do in my calculator, and that comes, actually, let me do that. Let me pull up my calculator. Hang on, let's see. Let me show you how you would do that in your calculator. We have E is up here. So if I do 0.07 times 6, it gives me 0.42, in case you weren't sure about that. So E is right above your division sign. So if I do second E, and then I raise that to the 0.42 power, and then I multiply that by 8,000, and that gives me $12,175.69. So $12,175.69. So you see it is a little bit better, but it's not you would probably consider that a nominal difference when you're dealing with really large numbers, right? It's about $15 difference roughly. Okay, so that's the idea. That's the difference between compounding a certain end periods of time versus compounding continuously. Okay, so that's everything having to do with exponential functions. Tomorrow we'll be talking about log functions. See you all next time. Thanks, everybody.